In this video, we will be talking about concentrations and dilutions, and also preparing solutions. Before we start, we'll just do a quick recap of calculating concentrations, especially molar concentrations, so calculating moles per liter. In the first example, we have what mass of solute is present in 40 milliliters of 6 mole per liter sulfuric acid solution. So in these types of questions, again, I always recommend just taking a second and identifying the information that has been given to you. Within this question, we're told the volume of the solution, which is 40 milliliters. We know the concentration of our solution, which is 6 moles per liter. Since we have two different units of volume, we will have to convert one of our volumes. It's easier to take our volume and take that milliliters and convert that into liters. So to get that into liters, we will divide by 1,000, and that will give us a volume of 0.04 liters. Now we're asked for what mass, so that'll be the mass in grams. That's ultimately what we have to find. The units that we are dealing with are moles per liter, and so we have units of moles. So ultimately we'll have to figure out how many moles we have in the solution. And once we know how many moles we have, then we can figure out how many grams of sulfuric acid is present. So now, to figure out how many moles of sulfuric acid we have, we are going to come back to that last concentration equation that we talked about the other day, where concentration in moles per liter is equal to number of moles divided by our volume. So remember, when we talk about moles, we are dealing in units of mole divided by our units of volume, which is in liters. So we have our concentration, we have a volume, we simply need to rearrange our formula so that we take our concentration, multiply it by our volume. That will give us the number of moles of sulfuric acid that we have in the solution. So we have a concentration of 6.0 moles per liter. We are going to multiply that by our volume in liters, 0.04 liters. When we multiply those two numbers together, we get a total of 0.24 moles of sulfuric acid. Now we're being asked for a mass of sulfuric acid, so the last thing that we'll need to do is then to take our number of moles of sulfuric acid and multiply that by the molar mass of sulfuric acid, and that will give us our mass of sulfuric acid in grams. So we know that we have 0.24 moles of sulfuric acid. We'll multiply that by the molar mass, which is 98.09 grams per mole. And that will give us a mass of 20 grams when we round for significant digits. So that is the first example question in dealing with concentration and calculations involving concentration. In the next example, take a few minutes and work through the following problem yourself. So in the problem, you're asked, what is the molar concentration of 1.2 grams of sodium nitrate dissolved in 80 milliliters of solution? If you do the calculations correct, the concentration that you come up with should be 0.2 moles per liter. If you're not getting that number, consult your neighbors or those around you, see what they got and what they might have done differently. So moving on into ion dissociation, and we're going to get back into a little stoichiometry. So in the previous examples, we've been dealing with questions where we need to find the concentration of a compound. What happens if we need to find the amount or concentration of an ion found in solution? So in order to do this, in order to find that concentration of an ion in solution, we have to combine the formulas that we learned in this unit and last unit. So now we're going to start building on the stuff that we learned last unit in terms of those calculations. We're going to expand upon the number of equations that we can draw on and use. So the equation that should be very familiar with you guys is equation for calculating moles, that mass divided by molar mass, and that molar concentration formula, that C is equal to N over V. Remember to use units to help you out. Units, if you're not sure how to proceed, can help guide the way. Generally, we're either trying to figure out a mass in grams, or we're trying to figure out a concentration in moles per liter. So if we're trying to get to that concentration, we know that we're trying to get to moles per liter. If we're trying to get a mass, we know we have to get to grams. Ultimately, both of these require molar units in there as well. And the last bit of advice is make sure that you do watch out for units. We already saw this in the previous example question where a volume was given to us in milliliters and we had to convert it into liters before we can proceed. So in the following example, we're asked to find the concentration of chloride ions when 19.8 grams of potassium chloride is dissolved in 100 milliliters of solution. So a few steps to remind you guys about before we work through this particular example. Just remember that everything runs through the mole. At the very least, you should be able to calculate the number of moles that we have within this question. So first thing that we're going to have to do is find the number of moles of potassium chloride. Then we'll find the number of moles of chloride ions, and we'll use mole ratios to do that. And then we'll find the concentration of chloride ions with our new formula. That's C equals N divided by V. So, working through this, one of the first things that we need to do is make sure that we have a balanced equation. So we're going to have to come up with a dissociation equation. We're told that we're dealing with potassium chloride and that this is dissolved in solution. So we are starting with solid KCl. And as this is put into solution, as it dissolves, it will dissociate into its ions. So we will have potassium ions in solution. We will have chloride ions in solution. And we need to just make sure that everything is balanced, and just looking at this, it is, we have one potassium atom on our reactant side, one potassium atom on our product side, one chlorine atom on our reactant side, one chlorine atom on our product side. Next thing that we'll do is we'll determine number of moles that we have in solution. So we know that we have 19.8 grams of potassium chloride that's being put in the solution. And we'll take that mass divided by its molar mass of 74.55 grams per mole. This will give us the number of moles of potassium chloride in solution, which is 0.26559 moles. Now, this is moles of potassium chloride, and ultimately we're interested in concentration of chloride ions. So we have to figure out how many chloride ions we have in solution. So for that, we'll go back to our good friend, the mole ratio, and we'll set up a stoichiometric relationship to help us figure out how much chloride ions we have. So setting up our ratio, we know that we have 0.26559 moles of potassium ions, potassium chloride. And we're trying to figure out how many moles of chloride ions this will result in. From our balanced chemical equation, we know that 1 mole of potassium chloride will give us 1 mole of chlorine ions. When we solve for x, we get the same number. It's a 1-to-1 mole ratio. So we now have our amount of chloride ions. Now, last thing that we'll need to do is calculate the concentration of chloride ions that we have in solution. So to calculate that concentration, we will use our C is equal to N divided by V. We've just calculated number of moles of chloride ions. We'll now divide that by the volume that is given to us. So we're told that this is dissolved in 100 milliliters solution. We want to make sure that we convert that into liters. And so when we convert that 100 milliliters into liters, we get 0.1 liters. And when we calculate our concentration, taking into account sig figs, we get a concentration of 3 moles per liter. In the following example, I'll let you guys work through this example. So you're asked to find the concentration of chloride ions when 26.5 grams of calcium chloride is dissolved in 150 milliliters of solution. When you guys work through it, the concentration of chloride ions that you should get should be 3.2 moles per liter. And I'll help you guys out a little bit by giving you that formula for calcium chloride, just to make sure you start off on the right track. So remember, it is CaCl2. So make sure that you take into account that subscript 2 when you come up with your dissociation equation. So we'll talk about preparing solutions and how we go about do that. So there's 2 ways in which we can prepare a solution. The first way is to dissolve a measured mass of pure solute in a certain volume of solution. And the second way is to dilute a solution of known concentration. So you can take something where you know the concentration of it, add in some more water, and you can create a new solution in this manner. So in the first manner, where we add a measured mass of a substance to a given volume, In order to prepare this, we need to use what are called volumetric flasks. Volumetric flasks are a specialized piece of equipment that we use specifically to make solutions. They are especially accurate because they measure a fixed volume of a solution. And they measure it to a very precise degree, generally at a particular temperature being 20 degrees Celsius, so about room temperature-ish. Picture at the side shows you what a volumetric flask looks like. It generally is round at the bottom with a narrow neck at the top. There is a graduation mark across that narrow neck that tells you how much you have to fill up the volumetric flask to. Volumetric flasks come in very specific sizes. So for example, this large one here is used to prepare a solution of 1,000 milliliters only. You wouldn't use it to prepare any other volumes. It would be inaccurate. If you wanted to make a solution up of a volume of 250 milliliters, you would use a 250 milliliter volumetric flask. So the steps involved in preparing a solution using a volumetric flask is that you add your powdered solute into the flask. You measure it out using a weigh scale or electronic balance. And once you have that, you add that into the flask. You dissolve your solute in the solvent, so half fill your volumetric. And then once it's dissolved, you want to fill until the bottom of the meniscus rests on the line. So that graduation line that we have on the neck of our volumetrics, that's where we want the meniscus to be. So looking at that more precisely, if we have our volumetric flask here we have our graduation mark. If we zoom in on that a bit more, the meniscus is that curved part of the fluid in that narrow neck. And we basically want the bottom of that meniscus touching the top of that line. We don't want to overfill our volumetric. If it goes too high, so if that meniscus is way over that line, it will throw off the concentration of our solution and it will not be accurate. If that meniscus is below the line, again, we don't have enough of our solvent in the flask and the concentration will not be accurate. So we want to make sure that the bottom of the meniscus is touching that graduation mark, and that will ensure that we've accurately prepared our solution. So we'll perform some labs later on where you guys will prepare solutions of specific concentrations using volumetric flasks. So we'll come back to that later on. We'll move on into talking about diluting a solution. So this is the second way in which a solution can be made. So you can make a less concentrated solution by taking a known solution and adding a measured amount of additional solvent to the known solution. When a solution is diluted, the important thing to note is that the volume will increase. So we increase the volume of our solution, but the amount of solute that we have, and we're talking about amounts in moles, will remain the same. So for example, in the beaker on the right, we have our concentrated solution. And just take a moment to note we have 1, 2, 3, 4, 5 moles of our solute in solution. We can add in more solvent to this solution and increase the volume. So in the beaker on the left, our volume has increased as we've added more solvent to it, but the number of moles that we have in solution has remained the same. So we still have 5 moles now, but just in a greater volume. So now we have same amount of moles, but more volume, and so our concentration will now decrease. So we now have a dilute solution. So now, when a solution is diluted, the volume will increase. However, the amount in moles remains the same, as we discussed. So we'll bring back into play our formula of concentration is equal to moles divided by our volume. Or if we rearrange it, we have number of moles is equal to concentration times volume. Now, since we have the same number of moles, what we can say is that the number of moles before dilution is equal to the same number of moles after dilution. So we haven't changed the number of moles, they remain the same. So the number of moles is equal before and after dilution. Now, if we take our number of moles and we sub in for it the concentration times volume into our equation, what we end up getting is a new formula that we can use, which basically tells us that the concentration of our solution times the volume of our solution before dilution, so before we add in more solvent, is equal to the concentration times the volume after dilution. We also refer to this equation as C1V1 is equal to C2V2, and is a handy way to figure out what a concentration of a solution would be after dilution, or a very good way to figure out how much volume of a particular solution we would need in order to get to a certain dilution. So let's look at example problem using C1V1. So for a class experiment, your teacher must make 2.0 liters of 0.1 mole per liter sulfuric acid. This acid is usually sold as 18 moles per liter concentrated solution. How much of the concentrated solution should be used to make a new solution with the correct concentration? So we can think of, let me go back to C1V1 is equal to C2V2. We can think of the C1V1 part as the concentrated solution. So we'll fill in that information there for that concentrated part. And the C2V2 refers to the diluted part, or the part that we have prepared. So going through our question now, we can organize our information into C1V1, C2V2 as given, and figure out what it is we need to solve for. So we're told that the sulfuric acid is sold as 18 moles per liter concentrated solution. So this is going to be our C1. So we can say our C1 is 18 moles per liter. We're told that the teacher has to make a zero point 0.1 mole per liter solution of sulfuric acid. So this is going to be our C2. We're also told that the teacher must make 2.0 liters of this 0.1 mole per liter solution. So in this case, this is going to be our V2, our diluted volume solution. Our V2 is 2.0 liters. We're also asking the question, how much concentrated solution should be used? So what volume of concentrated solution has to be taken? So in this case, our V1 is our unknown and what we are attempting to solve for. So from here, there's two ways we can proceed. We can take our equation, rearrange it to isolate V1, or we can plug in our information and then rearrange and solve. We'll plug in, rearrange, and then solve. So we know our C1 in this case is 18 moles per liter. V1 is what we're trying to solve for. We know our C2 is 0.1 moles per liter. We know our V2 is 2.0 moles per liter. When we rearrange our equation, we get 0.1 moles per liter divided by 2.0 liters. Need a bit more room. So we have 0.1 moles per liter times our 2 liters divided by our 18 moles per liter. Within this question, our units of moles per liter will cancel out, and we'll be left with units of liters. So we know we've set this up correctly, and we should get something that should be a reasonable answer. So when we solve for V1, we should end up getting 0.011 liters. That includes significant figures. And if we convert that into milliliters, which we don't necessarily have to do, but to put this into a bit of perspective, so when we convert that into milliliters and we'll multiply by 1,000, we'll get a volume of 11 milliliters. So what that tells us then is that therefore we can say the teacher needs 11 milliliters of the 18 mole per liter sulfuric acid. So in order to make up that solution of 2 liters of 0.1 mole per liter sulfuric acid, the teacher has to take 11 milliliters of that concentrated solution and dilute that to 2 liters. All right, so that does it for concentrations and dilutions. What I would like you guys to do is work on the ion dissociation problems and dilution problems found on the last page of the note.